Hi, good morning, everybody. I'm Howard Bernstein, for those of you who don't know me, and welcome to the Manchester stand at MIPIM 2013. The theme of our contributions today are around leadership of a city, the city's track record around invention, and we're promoting a very clear focus today around science and innovation, how that has transformed the world. A couple of years ago, we launched in MIPIM the significance of the graphene investment, and I can always remember a number of people in the audience looking at me saying, well, what's that got to do with property? Fundamentally, graphene is our way, along with other technological advancements and scientific discoveries, of creating for ourselves a capacity to be distinctive, a capacity which will drive growth, a capacity also in an increasingly complex global marketplace is going to become increasingly important in terms of our trading activities. The first part of our presentation is a film explaining the significance of the graphene discovery. Thank you.
Manchester, birthplace of the Industrial Revolution, home to the father of atomic theory, John Dalton, and the father of modern computing, Alan Turing. From Karl Marx to the contraceptive pill, from the co-op movement to the first hard drive, this city has been a constant source of new ideas. And now, well, Manchester is the centre of a new revolution, another globally significant, game-changing black swan event, and it's called graphene. And it was isolated here in the physics department at the University of Manchester. It's so extraordinary that in 2010, the scientists who made it were awarded the Nobel Prize for Physics. I mean, a story of serendipity and free thinking that rivals any in scientific history. These geniuses did what no one had done before and isolated graphene, creating the first ever man-made material in 2 dimensions. Graphene has almost limitless potential. It's so light and so thin, but it's strong and it's dynamic. The visions, the predictions of sci-fi writers and tech gurus are finally within our grasp. It is a carbon sheet, 1 atom thick, but 200 times stronger than steel. It's the lightest, most conductive man-made material on Earth. It can be used for DNA sequencing at a nanoscopic level. It can be programmed to attach itself to specific cells, like cancer cells, which will revolutionize medicine. It's almost completely impermeable. It could be fundamental to the storage and transport of fuels of the future. It stretches, it twists, it rolls to create bendable devices, not just touchscreens, but flexible, transparent components. Graphene devices will be able to carry electricity more efficiently.
A graphene string that is thinner than human hair could support the weight of a grand piano.
It could bring us the revolutionary possibility of electric planes.
In just a few years, we could all be wearing
graphene-laced smart clothing. We could be writing, tattooing, painting electrically conductive reactive inks. The list is endless. In the future, graphene's magnetic properties could bring particle accelerators into our laboratories instead of out on mountain ranges. It could be like having CERN on a desktop. And it is all because of graphene. And it was discovered here at the University of Manchester lab in a city that has always encouraged new ideas. The material of the future in a revolutionary city. It's a free exchange of ideas in a city of innovation. I mean, wow. See, for this city, it's not so much a question of where do we start. It's more about where do we go next?
Two more contributions now. First, Mike Emmerich, who's Chief Executive of the New Economy. Mike and his colleagues actually lead for us in the strategic approach to science as part of a wider economic strategy. And then Rowena Burns, Chief Executive of the Manchester Science Park. Rowena's been Chief Exec for some months now, since Bruntwood actually decided to work with us and revamp the science part. It's our response, really, to trying to create an integrated, single, commercially driven science and technology strategy. So first, Mike.
What does it mean? So what I want to try and do in a few minutes really is to talk about how we link science and its commercial potential, how we turn some of these ideas into commercial realities. Because science isn't just about discovery, it's about tackling the big issues. And we heard yesterday from Sally Davis, England's Chief Medical Officer, that in some areas science isn't keeping up with what bacteria and viruses are doing and that we don't have antibiotics. So there's a big global challenge to health. But if we get it right, science is very, very big business. It shapes places, as you can see in somewhere like Silicon Valley. And that's got to be our ambition for science in Manchester. And the question we've got to start with, and it's why we've asked the question for 3 years, is do people understand Manchester as a science city today? I don't think that they do. Manchester's recent past has been a success story of regeneration, property regeneration, physical regeneration, of turning our city into a major European centre again. It's been based on transport investment, the biggest public transport investment outside of London. And it's been based on music, the legacy of Tony Wilson and everything that went with Factory. But I suspect in the eyes of the public, Manchester's transformation has been above all else about sport. Manchester is in the top 10 cities in the world. On Olympics. Manchester is in the top 10 cities in the world for the number of medals won per head of population. And with the return of European success to Manchester through the European Cup and through the more recent exploits of Manchester City, we can claim that Manchester is in some senses the capital of the most interesting football league in the world. But how many people really see Manchester as a city of science? And yet, as we heard at breakfast this morning, that's what our city's always been. It's always been a city of science and innovation. But back 100, 150 years ago, we were seen globally as a city where science and innovation drove the economy. The challenge is for us to do that today, to turn science and innovation, the kinds of discovery we've heard about, into jobs and growth, into labs like that. Science is critical to the UK economy. It's critical to the global economy to meet the challenges that Sally Davis was talking about earlier this week and to deliver the growth that will go with that. The Chancellor of the Exchequer, George Osborne, set out 8 priorities for the UK for science. We are world class in all of them, and we are world leading in 4 of them, in our universities and in our companies. And those 4 are advanced materials, health innovation, nuclear engineering, and biotechnology. And I want to say a word or two about 2 of them now. The first one is e-health. Wrong way. Not many of you will have heard of Northwest eHealth, a long-standing project that brings together hospitals, clinicians, private sector, based out of Salford, where they've got some patented technology and are using it for what is now the world's largest clinical trial. GlaxoSmithKline have invested £35 million in the Salford lung study, taking 4,000 patients with COPD and 5,000 with asthma in a stage 3 clinical trial for a GSK drug, the largest in the world. But why is it happening in Manchester? It's happening because we've got the software, we've got the connectivity, the ability for GPs and patients to liaise directly with hospitals and the drug company that nowhere else has got. And it's happening now in Manchester. We've also got MIMIT. MIMIT, Manchester's Integrating Medicine and Innovative Technology Company, is the first and so far the only global affiliate of something called CIMIT, which is a similar partnership that exists in Boston, Massachusetts, between the universities and the teaching hospitals, bringing together scientists, clinicians to identify areas where new medical devices are needed, where innovation is needed, and seeking to put in place those devices to both to meet patient need and, of course, from a commercial point of view, to generate new activity. 22 projects in 4 years have been put forward through MIMIT, and the first of those products are now reaching the marketplace. So science and innovation are already an area of strength, and our ambition has got to be, and if this is the takeaway from this session, I think it's an important one. This should be our ambition, to complement what we've got in arts and in sport, and to make Manchester a very serious science city going forward. And of course, I have to mention graphene, because last year we talked about how we'd secured funding for the graphene, the National Graphene Institute. Last week, the final approvals were received from the European Union, and the building has got planning and is now in the process of construction. 7,500 square feet, one of the most sophisticated buildings of its kind anywhere, £61 million worth of investment due for completion in April 2015. Home to the largest concentration of graphene researchers in Europe, but also the home of several large companies with whom we are currently negotiating contracts for location. So what's next, very briefly? I'm happy to be able to say that we're working on a regional growth fund proposal for the fourth round of the regional growth fund that's about providing other support for our innovation economy, providing risk capital to the very earliest forms of commercialisation through proof of principle funding for 2D materials, including graphene, plus other kinds of companies, whilst also working on enterprise, providing support for student entrepreneurs as they graduate, and for existing small firms with commercial ideas that they might not otherwise have the wherewithal to take forward. In addition to all of that, we heard about MediPark last year, and I want to finish by saying a word or two about the North Campus at the University of Manchester. You will know that the University of Manchester came together through the merger of UMIST and the Victoria University of Manchester in 2004, and so existed on two campuses. The first of those, the bigger one, is the University Corridor area that Rowena is going to talk a little more about in a moment. What that's left is the North Campus area, and last year the university announced a £1 billion redevelopment of that area, and we're talking about the area between the Mancunian Way and Whitworth Street, north-south, London Road, and sort of Oxford Street area, east-west. And that is going to be the focus for the first part of that regeneration programme. We're working with the university and with Urban Strategies on master planning the area. The university will be moving to this campus, which is to the south of Oxford Road, and that North Campus area is going to come to the market over the next few years. Can't say much more about it today. Suffice it to say that in future meetings we look forward to telling you all about how this new Lebensraum for the city is going to become one of the most interesting commercial opportunities in Britain. And really, to finish, to illustrate the scale of this opportunity, if we take the narrow area of spinning fields at the top and the blue area of North Campus at the bottom, we're talking an area 3 times that of spinning fields, a major opportunity that is going to have science and innovation absolutely at its core. That's me done, but that's the future. That's something we're aspiring to and we're planning for. I want to bring us back to the present and to what Bruntwood with Manchester Science Park are doing today and how they're already driving at the forefront of the innovation economy.